So the first notes that I had sent were on limits, and if you remember very well, we had done a bit of limits on calculus 1. So it is not a new thing for you, because we had done something close to that. The examples that I gave you, the exercises that I told you to go and do, if you will have any issues, you will be able to tell me. So those notes are there. The most important thing is that the limit of a constant remains as a constant. The limit as x approaches infinity of 1 over x, that one will always go to 0, because you're dividing 1 with a very, very big number. So it should be able to approach 0. So those are the most important. The limit as x is approaching a constant. Basically, x is going to 2. You just replace where there's an x, basically with the value 2, and then you get basically a value. So those are the most important things, that maybe an overview of those. But right now, I want us to cover something new. Not the precise definition of limits that comes basically from the pure math definition. So it is a pure math definition, and you must be able to understand it. So it is a proof. So basically what we shall be doing, we shall be proving. So it's a proof, basically. A proof. Basically, given any limit, you don't calculate the limit, but you try to prove. So the precise definition of limit says, if the limit as x approaches c of f of x is equals to L, then there exist two numbers, one epsilon greater than 0, and a delta greater than 0, such that f of x minus L is less than epsilon whenever so these ones I'll be using these arrows, whenever x minus c is less than delta. That is the precise definition of limits. Basically, you want to prove a relationship between, what? Epsilon and delta. So if you can be able to prove there's a relationship, basically they are related, then you've been able to prove. So let me go back again. So we are saying the limit as x approaches c of f of x is equals to L. Then proof. We are saying there's an epsilon which is greater than 0, and a delta that is again greater than 0. And then you can be able to see the c is basically for the delta, the magnitude. When you come to the L, that is the answer that you are getting, and you have f of x. So everything you'll always be given. Your f of x is there, your L is there, your x and your c. And then now you need just to show a relationship. So what is our main goal? Show a relationship. Between epsilon and delta. If you can be able to show that relationship, then you are okay. Are we together up to there? Michael, you cannot be able to hear me? Or Michael is offline. So is it okay, Brian and Kimani? We want to show a relationship between delta and epsilon. So at least I do an example just to demonstrate that. Okay, let me just do an example, a simple example, then just to demonstrate what I'm saying. So this is the example. Proof. When I say proof, I'm using the delta and epsilon. That lim as x approaches, let's say 2 of x plus 3 We had done that one in the, let me choose a different x plus, let's say 8, x plus 8. X plus 8 will be given by what? Can you try that one? The limit for that one? Someone give me the limit for that one. The limit as x approaches 2 of x plus 8. Kimani? Run. What do you think the answer will be? The limit as x approaches 2 of x plus 8. What do you think the answer will be? We just replace where there's an x with 2. Okay, sawa. Kimani? Sawa. That's correct. 10. So you see now, I've already given you the answer. So I'm telling you to prove that the limit as x approaches 2 of x plus 8 is equals to 10. So there's no working because I've already given you the answer. So you know the answer is correct. So how do you prove this one? So solution. First of all, we shall identify everything. Our C is what? Our C is 2. Basically, as we approach this one here, then the whole of this one will be our f of x, and then the whole of this one will be our L from the definition. Our C is equal to 2, our f of x is x plus 8, and our L is equals to 10. So we are saying that there exists a delta greater than 0 and an epsilon greater than 0 such that uh, f of x is less minus L is less than epsilon. This implies what? This one implies that there will exist a delta such that x minus c will be less than what? Delta. So I'll just input everything the way it is. So remember my f of x is x plus 8. So I'll have the first one, I'll have x plus 8 minus 10 is less than epsilon. This implies that x minus c is less than delta. So we can be able to simplify on the epsilon side. When I simplify the epsilon, this is what I'll get. I'll get what is 8 minus 10? That is what? X minus 2 is less than epsilon whenever x minus 2 is less than what? Delta. Because we know 8 minus 2 is equals to what? Is equals to what? 8 minus 2, that is negative 2. So very, very important. So you can be able to see there's a relationship there. So now check this one out. We have x minus 2 is less than epsilon. Then we have x minus 2 is still less than what? Delta. We have two relationships there. X minus 2 is less than that one, and we have the other one, x is equals to that one. So this one can only mean if all of them are less than, we can be able to show a relationship basically. You can be able to say that because all of them are identical. Check this one out. This one, this function here, and this function there, it is what? They are identical. So we have the magnitude of x minus 2 is less than delta. Then we have the magnitude of x minus 2 is less than the epsilon. Which relationship can you be able to give me between delta and what? Epsilon. Which relationship can be able to give me between delta and epsilon? All of them are giving me the same thing. So what can we be able to say about delta and epsilon? Can someone try? What can you be able to say about delta and epsilon? The magnitude of x minus 2 is less than delta, is less than epsilon. The magnitude of x minus 2 is less than delta. So what can you be able to say about the two? Brian, do you want to try? Kimani? Oh, yes, okay. Kimani, can you try? Sawa. Kimani is typing. Let me just wait. Because if you understand this one, the next example will be so much easier. Yes, now, correct. They are the same because all of them are giving you the same thing. So this one signifies that delta has to be the same as what? Epsilon. And now you have shown that there is a what? A relationship. So if you can be able to show this, then we have been able to prove. We have proved. That is not the correct. We have proved. That's the end. We have proved. You don't know the question there? Is it hard? Is it hard? So basically, you just want to make sure that whatever that is on the magnitude is almost the same. So at least then you can be able to interlink them together. Let me do another example. So it is easy as that. It is easy as that to show the relationship. Let me do example number 2. Lim as x is approaching 3 of 2x minus 1. When you replace that limit, what are you getting? That is 6 minus 1, you get 5. So we prove for that one. We prove for that one, the limit as x is approaching 3 of 2x minus 1 is equal to that one. So solution. So this one is my C. This one is my f of x. And this one is my L. So let's do this one. Let's do this one. So remember we said the definition is what? That f of x, don't get that of repeating this one, is less than epsilon whenever what? Whenever x minus c is less than delta. So we just input whatever we have. So we have 2x minus 1, 2x minus 1. All of that one, we subtract our answer, which is 5. It's less than epsilon whenever our x minus what? Our c is 3. Our c is 3. It's less than what? Delta. So when you do the brackets, you'll get what here? You get 2x minus 6 is less than epsilon, and then x minus 3 is less than delta whenever x is less than delta. So now if we check these two, are they similar? Let's start from there. Are they similar, these two? Are they the same? 2x minus 6 and x minus 3, because that is, we want to show a relationship. Are they similar? Are they similar? I'm asking a question, Brian and Kimani. Are they similar? 2x minus c and x minus 3. Are they similar? One is a double of the other. Kumbe, you can easily be able to see quickly like that. Okay? I'm waiting for Mwangi to say something. So we can easily be able to see they are not similar. So when you reach there, the function that we normally manipulate is the function for the epsilon. If there's an equal sign with 2 at the end, they will be similar. Okay. Okay, it means they are double of one another. So this function here is the one that we normally manipulate. Normally we don't manipulate the delta. Delta we have never manipulated This function is the one that we manipulate to look something like x minus 3. Check this one out. If I factorize, 2x minus 6, I'll get what? 2x minus 3. So that's the manipulation you do. You normally you do the manipulation on the epsilon alone. So here you shall have what? 2x minus 3 is less than epsilon whenever what? Whenever x minus 3 is less than what? Delta. Now when you reach there now, we can be able to remove the 2 outside. We can be able to distribute the magnitudes. Distribute the magnitude. Distribute the magnitude. The magnitude. When you distribute the magnitude, you get what? The 2 can go on its own. Then the x minus 3 can be able to go on its own is less than epsilon whenever distribute the magnitude whenever x minus 3 is less than what? Delta. Now, the magnitude of 2 means what? The magnitude of 2 means that the magnitude for any positive number, it remains positive. For any negative number, it remains what? Negative. So we shall be able to remain with 2. The magnitude of x minus 3 is less than delta whenever x minus 3 is less than what? Epsilon. We are almost done. We are almost done. Now, our main work now is to make sure that on the left hand side we remain with the magnitude of x minus 3. So we have these two here. So we want to interlink the delta and the epsilon. So the only thing you can be able to do is to bring these two on this other side. So at least you can be able to have the same. You can be able to have at least the magnitude of x minus 3 on the left hand side. So how do we do that one? I'll divide by x minus 3. Sorry, I'll divide by 2 this side whenever, because I want to compare the delta and the epsilon is less than the delta. I want to compare the two. So I'll take the 2. When I divide by 2 both sides, the 2 will come there. Now, the relationship between delta and epsilon is easy now to be able to see. On the left hand side, we have similar functions. So this one can only be able to mean that what? That delta is equals to epsilon over 2. And that is the end of our proof, because we have been able to show a relationship between the two. We have been able to show a relationship between that delta will be given by epsilon over 2. Is it a bit clear? I can be able to hear from you. Michael, welcome. We are not that far off. We are on the delta precise definition. So you just have to make sure at least you show a relationship between delta and epsilon. Bran, Kemani, is it okay? So make sure that on the left hand side you have similar functions. On the left hand side you have similar functions. Michael, have you been able to follow that example? I can be able to do another one for you. So, but still you can be able to follow up on the video if you cannot be able to get me clearly. So let me do another example, number 3. Number 3. As x is approaching 93. When I do that limit, negative 3 times 5, that is 15. 15 plus 4, you get 19. So I've given you to prove that the limit as x is approaching negative 3 or that, or 4 minus 5x, you get 19. So again, I'll start from the nini. So this one is my what? This one is my C. This one is my f of x. And this one is my what? My L. So from the definition, we said what? We said that the magnitude of f of x minus L is less than epsilon whenever x minus C is less than what? Delta. So what is my fx? My fx is 4 minus, so I'll have 4 minus 5x minus 19 less than epsilon whenever x minus, now my c is negative 3, so I'm putting the brackets, less than delta, less than delta. So 4 minus 4x, let me just write it in a more better way. It's not that clear. You may get confused. So we shall have, let me repeat again. I'll have 4 minus 5x brackets. Brackets are very important to me. And then minus 19 less than epsilon. Whenever x minus minus, so I'll have x minus 3 is less than delta. So again, I repeat, we don't manipulate the delta so much, but the function that has epsilon, but you can be able to simplify. So 4 minus 19, you get what? 4 minus 19. 4 minus 19, that is what? 15. So we'll get, I'll start with the other one, 5x minus 15 is less than epsilon. And then here I'll have x plus 3 is less than delta. So you're in class, so kindly factorize for me this function. Factorize for me this one here. Factorize for me that one. Factorize for me that one and tell me what you'll get when you factorize that one. Factorize for me that one. We continue quickly. Factorize for me. I want you to do it. Michael, are you still following? Factorize for me that one. Brian and Kemani, factorize quickly. Okay. Yeah, you have gotten it. That's okay. No. What is negative 5 times negative 3? You'll not get negative 15. All of you, even Michael. Yeah. Brand, you have seen your mistake. Brand had not given me. Michael, that is wrong. It is not x minus 3, but x plus 3. You must be careful with your negative. So be careful with the negative. So I'll get a negative 5. And then x plus, not x minus. Sorry, this one is the bracket. Whenever x plus 3 is less than epsilon. By the way, the delta can easily guide you. The delta can be able to give you, we have plus 3, so you cannot have a minus 3 here. So from there, we can be able to distribute the magnitude. So the negative 5, and then the magnitude of x plus 3 is less than the epsilon whenever x plus 3 is less than delta. What is the magnitude of negative 5? So if you get that one, what is the magnitude of negative 5? The magnitude of negative 5. I want an answer. What is the magnitude of negative 5? Manning negative 5, okay. Another person. The magnitude of negative 5. No other answer. The magnitude of negative 5, 25, okay. No. No one is getting it. magnitude of negative 5. Okay, let me show you how you get it. So the magnitude for a single number, it is very easy. Okay, so if you take the magnitude of, let's say, a, that will be given by a squared, which will be what? Still a. Now let's do for negative 5. So negative 5 will be given by the square root of negative 5 squared, the same as the square root of 25. My pen is failing me. The same as the square root of. So on the magnitude, we don't take the negative answer. Same as the of 25, which is 5. So what are you seeing here? For the magnitude of any number, the magnitude of 2 will still remain it as what? As 2. The magnitude of negative 3 will become positive, shall become what? 3. The magnitude of negative 10 shall become what? 10. For any positive number, it remains positive. For any negative number, it remains. The magnitude of 20 can remain it as what? Still 20. Try this one out. The magnitude of negative 6. Give me that one. Magnitude of negative 6. Give me the answer now. At least I've given you an overview of magnitudes. You had forgotten. What is the magnitude of negative 6? No, it is easy. Okay, so it is 6. Correct, 6. 6. Simple as that. So the magnitude of negative 5 will remain as 5. So let's go back to our example. We shall have 5. Let's go back. At least we have dealt with the magnitudes of 5. X plus 3 will be less than epsilon whenever x plus 3 is less than delta. Sorry, that is the delta is less than delta. So what we need to do now, we need to have the magnitude of x plus 3 on the left hand side alone. So this 5 has to come this side. So we shall have what? Magnitude of x plus 3 is less than epsilon over 5 whenever what? X plus 3 is less than delta, which means that what? That our delta has to be the same as epsilon over what? Over 5. We are done with the proof. We are done with the proof. We are done with the proof. Anyone with a question so far? Anyone with a question? Anyone with a question? Have you understood a bit? Let me find out. Is it a bit clear? Is it a bit clear? The precise definition of limits. Is it a bit clear? Michael? Kimani, Brian? Let me see. Okay, so let me now go to a bit of a harder example now. I think we are number 4. I do a bit of a harder example. Okay, so lim as x is approaching. Let me see what I did on the. I don't want to do any example that is already there. I want to do different examples, so at least you can be able to understand. So I've checked 3 x squared is equals to 9. We want to do that one. The limit as x is approaching 3 of x squared is equals to 9. So this one is our C. This one is our f of x. And this one is our what? Our L. That is our L. That is our L. So again, I'll not get tired. So f of x is minus L whenever x minus c is less than what? Delta. So I'll put the first one. So I'll have x squared minus 9 is less than what? Epsilon whenever x minus 3 is less than what? Delta. Now check now x squared minus 9 and x minus 3. They are not similar. They are not similar. So we must be able to do something. So what have we been doing to make to have a function that is similar to that? I have x squared minus 9 and I have x minus 3. I want a function that is close to the x minus 3. What have we been doing in the previous example when we reach this stage? What have we been doing? There's a word that starts with f that we have been doing. There's a word that starts with f. What have we been doing? Yes. What have we been doing, Bran? A word that starts with F. Michael? A word that starts with F. Very important. When you reach that stage, we want to yes, factorizing. Very important. So we factorize x squared minus 9 is a difference of two squares. X squared minus 9 is the same as what? X plus 3. And then x minus 3. The difference of two, plus and negative, is a very famous one. So we shall have the magnitude of x, we distribute the magnitude plus 3, and then x, magnitude of x minus what? Plus x minus what? X minus 3 is less than epsilon whenever x minus 3 is less than delta. So I'll ask a simple question. So which functions are we supposed here now? Let me use a different. So which function here are we supposed to replace there? Which or in short, which function are we supposed to remain with on the epsilon? Let me start from there. Which function are we supposed to remain with on the epsilon? I'll start from there. Okay. Oh, so you're following x minus 3. That's correct. The function that we're supposed to have a relationship with must be x minus 3. So we must have a way of removing the x plus 3. But on the precise definition of the epsilon and delta, I can't divide both. Let me first of all do this one. Avoid this. Avoid. Because it is very important. You avoid this one, that x minus 3 is less than epsilon all over x plus 3. That one will be wrong. Why? Because we want to show a relationship between delta and epsilon in form of a constant, not a function. You can be able to see on the denominator, we have epsilon, then the magnitude of x plus 3. That is not a constant. It is not a constant. We must make sure that this function here, we must be able to make sure that this function here is a constant, not a function. You must be able to make sure that that function there is a constant, not a function. So avoid that. So for the squared, how do you navigate that? How do you navigate now? Because now we have a problem. So how do you navigate that? We had said that we choose a delta that is greater than what? 0. We said we choose a delta that is greater than 0. So we just choose a number that is close to 0. So we choose just a delta. Just choose a delta. Our choice of delta now is very important. We said our delta has to always be what? Has to always be greater than 0. So if I choose a value that is between 0 and 1, I think it can be able to work. So I can be able to choose a delta. So we always choose a delta that is what? Greater or equal to 1. That is, sorry, it is less than or equal to 1. It is greater than 0, remember our delta. So you are looking for a value that is very, very small between 0 and 1. And the only value that we can be able to think of that is close to that, we choose a delta that is always greater or equal to 1, always, for the squared. Because you remember our function here, our f of x was squared, is here. Our f of x was squared. So for the squared, if you go back to the examples I've done, we always have been choosing a delta that is less than or equal to 1. So at least we can be able to come and solve what? We can be able to solve the x plus 3. This is the magnitude of x plus 3. So we always choose that delta. Always choose that delta that is what? That is less than or equal to 1. Not any other number. So let me go back to what we have. This is what we have. X plus 3. X minus 3 is less than epsilon whenever x plus 3 is less than what? Delta. Together up there, I've just repeated what we had before. I've not manipulated anything. Now, check this one out now. We have chosen something. This one to help us to simplify the x plus 3. No, to simplify, have I interchanged anything? Let me check. It's still okay. So you told me I will remain with x minus 3. This one is wrong. I'm supposed to have x minus 3 here. Yes, x minus 3. X minus 3 there. So I need to choose. I've chosen a function here that I want to solve the magnitude of x. It will be able to assist me to solve the magnitude of x plus 3, so that I remain with the magnitude of x minus 3 on the epsilon. So how do I do that now? Check this one out. I've introduced something, so I can be able to say that when I introduce this one here, I can be able to say that now the magnitude of x minus 3 on the delta is less than delta. But again, our delta, I've introduced something, is still less than what? Is still less than 1. The magnitude of x minus 3 is less than what? Is less than delta. But again, I said my delta is less than or equal to 1. So this one can only signify one thing, that this function still has to be less than what? X minus 3 has to be less than what? Or equal to what? To 1. Has to be equal. X minus 3 has to be less than. Don't worry, I will show you I will solve this one. But first of all, only deal with the delta. Our delta is here. It was x minus 3 is less than delta. I've introduced something. So I've said my x minus 3 is less than delta, which is less than or equal to 1. Then x minus 3 has to be less than or equal to 1, basically, because this one is less than delta, but again, delta is less than or equal to 1. So you can be able to go to the final one now. Now we need to solve that inequality. We did this one in basic maths. Can someone be able to solve that inequality there? X minus 3 is Brand Mangi. X minus 3 is less than delta, not the opposite. No. We have said I've chosen what? My delta. Just bear with me in this example. The next example it will be a bit clearer. I've chosen a delta that is less than 1. Then check this one out. This function, the way it is, I've taken the way it is. X minus 3 is less than delta. But again, my delta is less than 1. So I've taken it on the like this. So it can only be able to mean that still the magnitude of x minus 3 has to be less than or equal still to number 1. It is mathematically still correct. Mathematically still correct. Mangi, I've not understood your question. But is it clear? The magnitude of x minus 3 is less than delta. But again, delta is less than or equal to 1. So it can only mean that x minus 3 magnitude has to be less than or equal to 1. I've taken the ends because I want to solve for that one. Oh, you are correcting. Okay, so do you remember how to solve this one? You guys, I showed you this one, how to solve this one. So this one is two inequalities in one. We have two inequalities. We have two inequalities. I think I had shown you how to do this one in basic maths. The first one is when you have positive x minus 3 is less than or equal to 1. The second one is negative x minus 3 is less than or equal to 1. So when I solve this one, the first one, when I solve this one here, oh, my arrow can be seen, diffusing. When I solve this one, I'll have what? X is less than what? Or equal to what? 4. When I solve this other one here, when I solve this other one, I'll have what? I'll have the x will go that other side, so the x can come this side. It's less than or equal to what? X is less than or equal. What is a negative times a negative? That is 3. 3 minus 1. To check if that one is correct, confirm if that one is correct, confirm if that one is correct. I've taken the first one was easy. I've taken the negative 3, the other side it became positive. The other one I've opened up the bracket, I got negative x, positive 3. Then I took the x the other side, then I brought the one this other side. So I get that one. So this one can be given as what now? I can be able to join this inequality. So the first one is x is less than what? 4. The other one, the arrow is pointing at where? At 2. And this one is less than 2. Like that. X is less than or equal to x. Like that. I've been able to join that inequality into 2. Been able to join that inequality into 2. Anyone with a question there on the inequality, or I proceed? Anyone with a question on the inequality? We always take the bigger number on the right hand side and the smaller number on the left hand side. The bigger number on the left hand side. The bigger number on the left hand side and the bigger number on the right hand side, the smaller number on the left hand side. Can I proceed, Bran? Kimani? Bear with me in this example. The other example will be much simple. The first example for the squared is always a bit hard. Okay. So I'll go back to what we had before. Let me go to back what we had before. We begin from the let me go back to what I had before. So this is what I had before. Check this one out. We had x plus 3. Don't ever forget where you're coming from. It's less than epsilon. The lever x minus 3 is less than what? Delta. That's what we had. And we have said we introduce a delta less than 1 to assist us to do what? To replace this one. So our main task is to replace this one. So we want to replace this one here. We want to replace with what? The constant. Replace with the constant there. So, and we have gotten a relationship here. So I'll use this one. I'll use this one to be able to assist me. This one. I'll use this one to be able to assist me now to solve for magnitude of x plus 3. How do I do that one? Check this one out. So we have what? We have what? I have 2 is less than or equal to what? X is less than or equal to 4. Now check this one out. So I want now to solve for the magnitude of x plus 3. That's what I want to replace. It's less than, it's less than. So what will I do? Now check this one out. I have x is what? Is less than or equal to 4, but it is greater than or equal to 2. But now I have x plus 3. So what I'll do, I'll add now. What I've done on the x, I've added a 3, and it's a magnitude. So when you have a magnitude, you're allowed to do this. 3. Then this other side will have 3 plus 2. So check, I'm just adding the way it is. Let me rub again and repeat what I've done here. So I'm comparing the two. So what have I done? So I have here plus 3. If it is negative, I'll add negative, but it is plus 3. So I'll add now. If you take this one out, you'll add here plus 3, and this other side you are adding plus 3. Only that. You compare just the two, because you had an x, you added plus 3. So you add a 3 on the left and you add a 3 on the right. Easy start, because we have magnitude. It does not work with any other function when you have a magnitude. So you'll get 5 less than what? 5 is less than or equal to x plus 3, less than or equal to what? 7. That is the magic we do. So you can be able to bear with me and see why we were. Someone is saying a refresh on the screen. So I'm refreshing the screen. I will repeat again. So this is what we had. We had we solved for this one. Then you had this is what we wanted from the beginning. X plus 3, x minus 3 is less than epsilon. X minus 3 is less than delta. So we wanted to replace this one with a constant. So how are we replacing that? Remember our function that we had solved for the delta. 2 is less than x is less than what? 4 or equal to 4. So what I have done, because I have magnitude, I have here plus 3. So I've added plus 3 and plus 3 on the right. So I'm adding plus 3 this side and I'm adding plus 3 this side. To get 5 is less than or equal to magnitude of x plus 3, which is less than or equal to the magnitude of what? Of 7. So that is basically how you do it. Basically, how that's how you do it. So which value will you pick now here? Which value will you pick here to be able to satisfy our inequality? I will recommend you to take this value here. So we ignore this one, because remember our delta, you remember our delta is always less than. So I'll take only this value here. I'll only take this value here. This one is the one that I'll take. Only that one. The magnitude of x plus 3 is less than or equal to 7. I will ignore the other one. I'll just ignore the other one. So it is less than or equal to 7. So I can be able to take to take the biggest number, which is what? Say 7. Which is 7. So I'll take the biggest number, which is 7. So it means that what? X plus 3 can be replaced by 7. Can be replaced by 7. So I'll go back to what I had now. I had had I had x plus 3, x minus 3 is less than delta whenever x minus 3 is less than epsilon. So we have said that when I'm replacing with 7, so 7 x minus 3 is less than whenever what? Whenever x minus 3 is less than delta. And the relationship that is there now, what I'll do, I'll take this 7 here and take it on that side. And take it on that side. So I'll have x minus 3 is less than epsilon over 7 whenever x minus 3 is less than delta. So we have the same thing now. We can easily be able to say that delta is the same as epsilon over 7. Delta is the same as epsilon over 7. So I've taken the biggest value, and which is equal to that. The other value is less. So I've taken the biggest value to be able to demonstrate that. I think I can do another example. Let me just do another example to demonstrate what we have done. Because if you understand another example, that one was just one example. So limit as x is approaching lim as x as x is approaching 4 of 2x squared minus 1, that is you'll get what there, that is 16. It's a big number, so let me just reduce this one and have a bigger number there, because I'm seeing it is going, we can say we can have 20 x squared minus 20, that is 16 times 2, 32, 12. We prove for that one. 2x squared minus 20 is equals to 12. So again, I'll go back to the definition. So, but again, I'll have to do some. I'll have to get some things from this equation. So here, this one my c, my f of x. This one is my. So let me now have what I think I can be able to jump basically now. We had f of x, that is 2x squared minus 20. Subtract our L, which is 12. It's less than epsilon. Whenever what? X minus c, that is x minus 4, is less than delta. So let us solve whatever that is here first of all. When you solve, what do you get? When you solve this one, you shall get negative 20 minus 12. That is negative 20. That is what? Negative what? 32. It's less than epsilon. Whenever x minus 4 is less than delta. Then you said we can be able to factorize first of all. That one is not remember, we can't get the square root of 32, so it is not a difference of two squares. It's not a difference of two squares. So first of all, we manipulate this one. So I'll have 2x squared minus 32, but still we shall factorize. First of all, if we factorize the 2, we remain with x squared minus 16. Now this one is a difference of two squares now. So this one will be the same as 2. Now this one will be x plus 4, and then x minus 4. There is a difference of two squares because you can be able to get the square root of 16 when you have a minus. So what shall we have now? We shall have 2, and then x plus 4, x minus 4 is less than delta whenever x minus 4 is less than what? Delta. So which function do you want to remain with? Again, I'll ask that question. Which function do you want to remain with? Which function do we want to remain with? Which function do we want? Okay, I've seen one answer. Which function do we want to remain with? Brian, which function do we want to remain with here? Which one do we want to eliminate? Okay, Sawa, that's correct. We want to remain with x minus 4. So already we have a constant here. So the constant has no problem. It's a good thing. But the problem is the x plus 4. So we need to replace the x plus 4. How do we do that? How do we replace the x plus 4? We need to choose our what? We need to choose a delta that is less than or equal to 1. So we choose a delta to be less than or equal to 1. So I'll use this function for delta. So x minus 4 is less than delta, which is less than or equal to what? To 1. So this one can only be able to mean 1, that x minus 4 has to be less than or equal to what? To 1. You guys have shown you how to solve the other one. So for me, this one. Give me the first answer for x, the two inequalities. Give me now, solve for that one. Solve for that one quickly and give me the values. So for magnitude of x minus 4 is less than or equal to 1. Kindly solve quickly. Give me the first value. You can use words. You can use less than or equal to if you don't have those in between. But I need a value between x and what? We need x is what? The first one, x is less than what? And begin with the first one, x is less than what? X is less than. Yes, at least Kemani has gotten it. Brian, you'll have to give me the second one now. Kimani has been able to give me one. So the first one is what? We said this one is the same as positive x minus 4. Sorry. It's less than 1. So this one, the answer is what? X is less than or equal to 5. Now the other one is the minus x minus 4 is less than or equal to 1. So I wanted you to be able to solve that one. So you can be able to give me here x is less than or equal to what? Give me that one, Brian. I'm waiting for Brian. Brian, quickly. Let me see. Are you correct? For yes. That's correct. 3. So true. That is okay. 3. That's okay. 3 because a negative times a negative is positive. So what we have now, we can be able to join these two together. Let's join these two together. So we shall have this one now. The first one is the bigger number is what? 5. And the smaller number is what? 3. So is it okay up to there? Now we go back. You had told me you wanted me to replace x minus 4. So that's what you are replacing x my so at least we remain with x plus what? We remain with what? We remain with x minus 4. So how do we do that? We shall just use this inequality. So less than we have here we have 3, then we have x plus 4. That's what I want us to replace. It's less than 5. So what have we done here? What have we done on this inequality? We have added 4. So what I'll do, I will just add a 4 this side, and I will just add a 4 that side. So 7 has to be less than x plus 4, magnitude of what? 9. So you just use this one. You use this one to get this one. Only that. So you have, when you have magnitude, you are allowed to do this. When you have magnitude, you are allowed to do this. So we can only be able to come and take this one. We take this one, is the one that we take. So it means that x plus 4 we take has to be the same as what? 9. X plus 4 has to be the same as 9. So let's go back to what we had now. We had this one, we had 2. We had x plus 4. We had x minus 4. It's less than epsilon. Then x minus 4 is less than what? Delta. That's what we had. So we have been able to replace some of these things. So x plus 4, we shall have what? 9. The magnitude of 2, I can easily simplify. The magnitude of 2 is still 2. I think I've shown you how you get the magnitude. So you shall have 2. You shall have 2. It remain the way it is, 2. Then we shall remain with 9 here. Then the magnitude of x minus 4 is less than epsilon. And then x minus 4 is less than delta. Can someone give me a relationship between delta and epsilon right now? Someone to give me a relationship between delta and epsilon, the final answer. A relationship between delta and epsilon. Delta will be what? Delta will be equal to what? Bran? Kemani? Delta will be given by what? Want to see some answers. Delta will be given by what? Try. Delta will be given by what? A relationship. What will be the relationship? Imani, you are not typing? Oh, you are typing now. What will be the relationship between delta and epsilon? Delta is equals to what? You can use the word delta. The other one is epsilon. You can use E. Oh, so Kimani? Waiting for Kimani. If he has been able to understand this one, then we are okay. Yes, you guys are correct. Over 18, yes. So this one we shall have, that's correct, x minus 4. Magnitude of x minus 4. X minus 4 is less than epsilon over 18, which is x minus 4 is less than delta. So it means that what? Delta is the same as epsilon over 18. And we are done with the proof. So this is basically it is a proof basically. Someone came up and said that now if I wanted to prove basically, I must be able to show a relationship. If there's no relationship, then we can be able to conclude that that limit does not exist basically. It is not correct basically. If you cannot be able to find that relationship, it means that it is not defined at that particular and it is wrong. So it is just a pure maths way of proving what limits. Anyone with a question or an example they want me to do, because that's what I wanted to cover for today. At least it is good. We shall again, when you come to functions, we shall be able to still do almost something similar to this one. But is it a bit clearer? These are examples that are not on your notes. I love to do as many examples as possible. So these are new examples. So if you go through the notes, you'll find other examples and you can easily be able to follow. That is my main task. I do different examples in class, and then you guys can be able to follow the examples, and then you can be able to try to do the exercise. Brian Mwangi, any questions? Kimani Ngugi, any questions? Okay, none. Okay. Kimani? I'm good, sir. So kindly, Mwangi, I think you tried today to tell your classmates to come. Some tried, some were not successful. Tell them when you come to class, they'll be able to understand better the notes. Kindly tell them to come to class. And then tell them if they miss this class, there's a video. This video, they can easily be able to follow up. They can be able to follow up on how to be able to do the limits. So with that, can I wish you a lovely day? I'm done for today. Can I wish you a lovely day? Yes. So have a good day.
You are currently the only person in this conference. You are currently the only person in this conference.